is Mike Higley. I'm a systems architect for SDI, and I've been in the material handling industry for 20 years. What is SDI? They're a leading logistics capital equipment manufacturer, and our primary product is Bombay unit sorters, hang sorters, tilt sorters, ways to take items that go into a box and move them around to get them to that location. We also sell one of our newest product lines is called a Joey pouch sorter, and we'll get to that in a few slides. Our steel manufacturing is located in California. Our high voltage cabinet manufacturing is in New Jersey, and in Florida here we actually have our technology center where our software and our controls engineers actually build out and test our primary software suite. Our bread and butter, though, is actually unit sorters. That generally is what gets us into the warehouse or distribution center. But we're also very comfortable actually building out an entire warehouse solution from scratch or from a grass field. Some of our customers, our majority of our customers are retail customers like JCPenney's, Nordstrom's, Lulu, but we also do work with some of the larger 3PLs like Geodis and Maersk. Majority of our customer base is in the U.S., but we actually have places worldwide. Majority of it's in the U.S., next largest sections in South America, and the rest of it are actually parts beyond. So some of the trends we're seeing in automated material handling for smart manufacturing. One of the most abrupt trends we've seen was caused by COVID. It has caused companies to reevaluate how much they actually invest in automation. Whereas automation has strictly been seen in the past as ways to reduce labor or handle growth, it's now also seen as a key resource to actually mitigate risk. Another changing trend is around how we go about actually doing that implementation. For example, does your solution adapt well to the changing landscape? In the past, when we've developed unit sorters, we build them to do one specific thing very well. In most cases, it was either this piece of capital equipment was built for e-com, does e-com based orders, or this piece of capital equipment was built to handle our retail sortation to our stores. Now we're being challenged to actually use the exact same equipment to do both. And also one of the challenges with the buying patterns that have changed for our customers is returns, where returns are actually up 20 to 30%, and yet most distribution centers today still process 100% of the returns by hand, no automation at all. So then we throw returns into the same mix. So today customers are asking us to quote and build out solutions that do everything under the sun. I wanted to do e-com. I then wanted to do returns. I also wanted to do retail and off hours. Another trend we're seeing in our customers is us asking for more analytical data actually provided by these machines. So just dropping the machine on the floor isn't sufficient anymore, and having it do every possible combination of sortation. We also want to be able to pull analytics off of it. What's the uptime on the machine? What's the cycle rate of every single piece of device and I/O off of it? They're taking that and they're pushing it up into the cloud to start running AI analytics against it, and it provides proactive excessive wear metrics, and they're able to proactively actually start providing maintenance instead of dealing with it after it breaks or just sticking to a more rigid PMing plan. We're also starting to see that we're able to do predictive trending in performance to actually mitigate performance spikes. So when new increases in like e-com demand come down the pipe, then the machine's not properly staffed with labor, we begin to see that the warehouse ends up becoming a backlog. Predicting those demand spikes and then proactively getting labor ahead of there allows them to match the demand in lockstep. But without the data coming off the low-level machines to generate that statistic, you're just reactionary. Also, an interesting note on that as well is one of the barriers we're seeing as we begin to push into grass field environments or even older ones is the IT infrastructure. They're looking for us to actually do less with more. It's going to be kind of a running theme I've seen here in this forum. but they want to see us fit everything we're going to do into one rack now. It's a warehouse. They want the smallest amount of IT infrastructure as possible. How do we reduce the learning curve for our IT infrastructure? How do we reduce the number of vendors they have to support? How do we put it in small and lesser racking? Material handling for smart manufacturing shares a lot of the same challenges that I've seen presented here at this forum with other speakers. A solution builder, I guess us as solution builders for our customers are constantly being challenged to find ways to do more with less. Commonly, we see our customers asking us to match or exceed my current rate and put it into a smaller footprint, use less labor and perform the same workloads and output, and ideally all of the above, while maintaining accuracy and data integrity and quality. The ultimate measurement is generally ends up being cost and efficiency. Traditionally, these are viewed as the same thing, but in material handling, it's not always the case. We actually see efficiency having a lot more in common with cadence, where in a warehouse facility where you end up with a lot of links in a chain that tie together one back to back with the next one, taking the overall process and actually slowing it down to generate a cadence will actually give you a better throughput and higher rates to the entire building, and they end up referring to that as efficiency. So in this case, harmony equals efficiency. Efficiency ends up equaling constant rate of the warehouse or DC as a whole. This was part of the challenge that was presented for a project we did for Dillard's. Dillard's needed an e-com solution that could handle 6,000 units an hour and needed it to fit inside of a space that was 25% the size of a normal traditional unit sorter. Our answer was a Joey sortation system. It's our newest sorter in our portfolio. And what makes the system unique is that we're actually able to put it above all the existing equipment in the building. So once you've run out of floor space, where do you go next? In our case, we go up. Not only is this system actually able to handle sortation that needs to handle their needs, and be able to support a huge variety of product lines. So these pouches, we could put everything in it from lip balm to a box with boots in it, or even create eyelets where we can do hanging garment, all with the exact same platform. And in addition to just sorting them, with it being up in the air, we can actually use it to handle our storage as well, kind of like an auto storage and retrieval system, and sortation merged into one. The downside, though, is that this system ended up creating some unique new challenges, with it having over 138 Cognex cameras, and with the system transferring pouches between these cameras at about 3 pouches a second, we end up with 800 barcode scans a minute. And that's just the destination requests. Once we add in divert, confirm states, statistics generated across the entire machine, changes states of all the individual devices, we actually end up with a system that's generating about 4,000 megs worth of data a second. So when we start looking into like storage solutions that can actually handle a database that's generating really 4 gigs of data a second, you have a brand new challenge on the table that most warehouses are very unaccustomed to having to deal with. So, and on top of that, we can't afford to have downtime. We need redundancy. So how do you bake redundancy, and in our case, redundancy at a fault-tolerant level with a system that can actually handle a 4 gig per second write rate forever? Because when these systems turn on, you push the gas pedal to the floor and you hold it there for decades. In addition to this, we actually made a business decision to try to become a bit more agile. When it starts talking about smart manufacturing, how do you do more with less? How do you allow your system to be more adaptive? Customers don't want to hear that I've got a lot of customization, so it's going to take longer. They want to hear, we can do customization, and we can do it and still hit our normal delivery times and still have it fold within the same portfolio of our baseline. To facilitate this, we actually took our PLCs that run this equipment and we normalized them down as much as absolutely possible. And we took a lot of our business rules, a lot of our decision-making logic that historically would live in a PLC, and we moved all of it into SQL, into a database. That just take this existing problem and compounded it even more. But what we got out of it as a return was a system that was incredibly flexible. If you needed to add new directional logic that needed to piggyback off of new parameters we've never used before, We simply added it as another criteria into an existing data structure model. We didn't actually have to go touch the PLC or teach it how to handle these new inputs. That was simply an abstract object that passed it up. But again, now we're putting more and more burden onto the compute module. So fortunately for us, we'd already been working with Stratus to handle our redundancies, handle our redundancy levels actually at a fault-tolerant level, and have been doing it for several years. The F2 server was actually able to scale up to the I/O needs that we ended up incurring with this solution without increasing complexity, without adding risk, and just kind of doing it right out of the gate. And although with that in mind, our customer actually did come back and ask us to try to see if we could take the same solution we were providing by Stratus and use their existing infrastructure, because hey, Mike, we've already got a 3-tiered architecture. We're just going to spin you up a VM and throw your database on that. It should be fine. And what we found is that in both 3-tiered architectures and hyper-converged solutions, that when you start talking about like 4 gigs a second actual write rate, that they can't keep up. It's normally the bottleneck ends up being the network. And when you evaluate what does it take to actually scale that network up enough to be able to hit those numbers, it's not cost effective. It ends up sometimes costing more than the actual capital equipment we're selling. In this case, though, we now have a fault-tolerant solution that cleanly scales and actually fits within the normal budget we see needed for these type of deliverables. Previously, I talked about trending patterns we see in automated warehousing with the reduction of IT. Part of that too is we're actually seeing where we're going into existing customers that we're upgrading, and we're able to pull out 3-tiered architecture, put in a Stratus box, actually reduce our amount of rack space we're reducing in half, and get rid of 3 or 4 different vendors with a single one. And in doing so, we actually reduce the how large the area is we have to support with our support contracts, and the number of vendors our customers have to manage as well from an IT standpoint. Again, both of those are pushes that we're trying to meet that expectation from our customers. One of the things that we also found is very beneficial as a company that's heavily reliant on uptime. Having a system that's actually smart enough to proactively identify hardware exceptions due to thresholds. So when hardware begins to slightly deviate from what's considered normal, it can be identified and proactively replaced. And that I guess proactiveness is not something we've seen in a lot of the other hardware manufacturers, and yet it's something that's served us incredibly well in an environment that has to run this type of complex equipment for, and a lot of our customers actually run 24/7. Their only service window is a Sunday, and that's only if everything else comes perfect. Whereas if they get a large hit in e-com, that Sunday's gone. So you don't have a service window anymore. Being able to proactively handle that hardware and take it out before it's hit that critical level is served us very well. Also, a lot of our machines, their primary interface with our customers is an HMI. Most of our HMIs are pulled over the OPC protocol, and we've had other speakers talk about OPC UA. And we use that for our main front end. Most of our customers, that's their single pane of glass that interacts with our capital equipment. We are now actually able to take the server health status and indicators and tie that directly into the same HMI our customers are seeing, getting us closer to a single pane of glass for an entire piece of capital equipment. These are some of the key results from our business that were directly attributed to the combination of both moving our PLC code to our database and by using Stratus to overcome the challenges that interaction caused. This is how our business has evolved to meet our customers' changing demands. Again, how do we handle that digital transformation and some of the challenges that come along with it. Our on-site commissioning time has actually been reduced under 2 weeks. Historically, it's been closer to 4. And as a business, we were pushing to see how do we move that the on-site commissioning time down. with having a consistent hardware platform now and being able to build the stuff out in-house and have a consistent deliverable that doesn't change from time to time, whereas some of our previous vendors that provided the same type of clientele, the hardware was constantly changing. We couldn't go 4 years with the exact same type of deliverable. It would change. And then we'd find out what those changes are when we're trying to commissioning, trying to deal with, oh, this has got a new hardware in it. Oh, it's got a new driver. That driver doesn't support such and such. And now we're all standing around waiting for a way to try to get our vendor to build a new driver while we're in the middle of actually commissioning a deliverable. Reduce service interruptions via fault-tolerant redundancy level. This has directly led to actually just less support calls. If the system doesn't fail and it doesn't go down, we don't get calls in the middle of the night with a customer going, we've got a 9 a.m. fire, put somebody on a plane. And again, as a side effect of that, by actually reducing our IT vendor pool, we've actually reduced the complexity that we're seeing in the support tickets we still do deal with today. Whereas, again, one of our challenges and push was, okay, when we do have a support call, how do we get the complexity down? How do we get our support calls not only to be less, but to become less complex? Downtime at a distribution center can cost a retailer as much as $1 million a day. And Stratus platform is one of the ways we actually help prevent that. SDI measures Stratus not just by the value of risk avoidance, but by the relationship and credibility that comes with delivering a bulletproof solution that runs for decades.